Find the y-intercept, if any, x-intercepts, if any, vertical asymptotes, if any, including the asymptotic behavior on each side, and holes, if any, for f of x equals x squared minus 6x divided by x cubed minus 6x squared. The first thing to find is the y-intercept. This is where the function crosses the y-axis, defined by x equals 0. The corresponding y-coordinate can then be found by plugging the 0 in for x in the function, which will give 0 squared minus 6 times 0 divided by 0 cubed minus 6 times 0 squared. 0 squared is 0, minus 6 times 0 is 0, divided by 0 cubed is 0, minus 0 squared is 0 times 6 is 0. 0 minus 0 is 0, giving 0 over 0. This is not a limit, so this is not an indeterminate form. That 0 in the denominator actually is a 0, which is not allowed, and therefore there are none. The remaining parts are found by taking the function f of x, which is x squared minus 6x divided by x cubed minus 6x squared, and fully factoring the numerator and denominator. In the numerator, there is a common factor of x, leaving x minus 6. In the denominator, there is a common factor of x squared. Factored out will also leave x minus 6. And now canceling any like factors, the x minus 6's can cancel, and one of the x's can cancel. This leaves a 1 in the numerator, so it reduces down to 1 over x. The x-intercepts are found by taking the numerator and setting it equal to 0. X-intercepts are where it crosses the x-axis and it corresponds to y equals 0. We take the numerator, set it equal to 0, and solve for x. There is no x to be able to be solved for, therefore there will be none. Vertical asymptotes are found by taking the remaining denominator after canceling everything out and setting it equal to 0. It looks like x equals 0 will be the only vertical asymptote. We can now analyze the asymptotic behavior on each side, found by taking the left-sided limit of 0, using the factored version of the function, and the right-sided limit of 0, also using the factored version. Let's start with the left-sided limit. The left side of 0 means a negative number. When plugged in for x, that's making the 0 in the denominator, it will then be a negative number, but it'll be approaching to 0, so we can replace x with a negative 0. 0 can then plug in for any remaining x's. There are no other x's, but it will give a 1 divided by a negative 0. That 1 in the numerator is a positive 1. Positive over negative is negative. Non-zero over 0 is an infinity. The right-sided limit can be analyzed in a similar fashion. The right side of 0 is positive numbers. When plugged in for the fact that it's making 0 in the denominator, which is the x, it will be a positive number, but it'll approach to 0. So x can be replaced with a positive 0. 0 can then plug in for any remaining x's, giving 1 over positive 0. The 1 in the numerator is positive. Positive over positive is positive. Non-zero over 0 is an infinity. And there's the asymptotic behavior on both sides of the x equals 0 vertical asymptote. Last of all, we want to find any holes. Holes occur for any factors that cancel in the factored version of f of x and fully cancel out of the denominator. Now, x partially canceled, but there was an x that ended up being left over in the denominator, so that means that was a vertical asymptote. But we had an x minus 6 fully cancel out of the denominator. that means that factor will be making a whole. So it's going to occur when that factor that fully canceled out of the denominator is equal to 0. X minus 6 equals to 0 solves for x equals 6. The corresponding y-coordinate can be found by plugging that x-coordinate into the function using the fully factored and canceled version, which is the 1 over x. So f of 6 will be 1 divided by 6. We have an x-coordinate of 6 and a corresponding y-coordinate of 1 over 6. And there's where a whole would be found.